Good evening and good afternoon. So my name is Radu, and now I want to show the capabilities of the platform that we have. So once you registered via our website with a 1 month free trial, you will reach this dashboard in which you have two modes for doing machine learning. One is the train mode and one is the live mode. Now, in the train mode, you construct a machine learning model using some input historical data. And in the live mode, you will construct predictions. You will have predictions on new data. Now, first of all, we don't have a model trained yet, so we will create a new one. So I will click on the train mode. And now you need to upload the data set. So as Ernie suggested previously, we are going to use for this demo, we are going to use the S&P 500 monthly returns data set, which will be available in the dashboard after this webinar for you to try it. The data set is ranged from January 1945 up to November 2019. And in the returns column here, you can observe two classes, 0 and 1. A 0 class occurs whenever the future monthly return is negative or 0. So we label it as 0. Whereas a 1 class occurs whenever the future monthly return is strictly positive. So, for instance, in this one, in November 1945, it is indeed the case that the future 1 month return will be strictly positive. Now, the following columns includes both fundamental and technical macroeconomical indicators. And first of all, I want to point out where do the feature come from. And this feature, for a better explanation of these features, please consult this paper. It is called A Comprehensive Look at the Empirical Performance of Equity Premium Prediction. But just as an overview, we include dividend price ratio, dividend yields, earning price ratio, dividend payout rate, stock variance, treasury bill rates, etc. So now the idea is you are constructing a machine learning model, a supervised machine learning model using these features, which might be included in both fundamental and technical macroeconomical indicators. And we will have the returns as a as a target variable. So now let me just upload it and click on the next. Let me go to it. Okay. And after you have clicked on next, you will have a form to complete for constructing a machine learning model. Basically, you as a user can customize it using different options, can customize the training. So first of all, you will need to input the name of the data target variable. In this case, this is it's called returns, right? Now you see here that the data file is under time series format, so I will click on yes. If you leave the option set to yes, you will make the feature stationary using the technique of fractional differentiation, which was popularized by Dr. Marcos Lopez de Prado. The target variable is under class format, since what you are trying to predict are two classes. So this problem is considered as a binary classification problem, but We also allow multi-class classification and regression problems. And the feature selection algorithm that we want to choose for this presentation would be cluster MDA. And for speed purposes, I will leave the level of machine learning hyperparameter optimization set to none, meaning that the model will be trained using some default values that are found in our user manual. So we don't actually do for this run, we don't actually do the hyperparameter optimization step. The size of the test set, I will deliberately put it as 6%, meaning that the first 94% will be kept for training, whereas the last 6% of data will be kept for out of sample predictions. Now, the reason for using this is because that will correspond to the 2016 up to 2019 data, which will be used for out-of-sample testing. The type of ensemble, I released the type of ensemble learning to the gradient boosted decision tree algorithm. Sample weights, probability calibration are different techniques that are used that you might choose to customize your model, but for this demo, I will leave it as the default values. I suggest to use the exploratory data analysis because this will allow you to find any outliers or errors in your input data. And in the file suffix name box, you just need to fill in a name for your machine learning model. So I will do just that. Okay. So once you are satisfied with it, then you can click on Run Model. And you see here that now it's performing the cluster MDA step. Okay. Now, once you have obtained the results, so if someone is interested in the size of the data set, I forgot to add that this data set is about 900 rows and for about 14 columns, right? So this is a public data set. So once you have received the results link, you will receive it either both via the email that you provided for registration at the registration step, and you have it in your browser. So once you click on that, you see here the results page section, and in the results page section, you see information about both in-sample and out-of-sample data. Since it's a public classification data set, the predictive power is not great. You will see here that it's still better than random, but specifically for the test set, right, which is range from mid 2015 up to November 2019. Indeed, the accuracy is superior, but the AUC score, so we offer 3 performance metrics at the moment, the accuracy, the F1 score, and the AUC score. And all the performance metrics will need to be taken into account when deciding when the model is appropriate to actually be used in live trading. So for the test set, although the accuracy is good for finance, usually an accuracy greater than 55% is decent for finance. You will observe here that the AUC score is less than 0.5, i.e. the under curve score is quite inferior. So we cannot conclude that the model trained using the this SPX public data set is actually something that you would use for live trading. But nevertheless, I want to show the output of what you can get from this platform. So I want to point out that a good model is also constructing using good features. So if your features don't have predictive power, then indeed your performance metrics will not be the best. Now, I want to go to the resources here. So first of all, you have some simple information about sorry, you have some simple statistics about your input data set, such as mean, standard deviation, minimum and maximum, and percentiles for every column in your input data set. Now I want to briefly go to the other outputs, all right, such as the cluster output. So as Ernie mentioned, for this public classification data set, you have two clusters, one with importance score of 0.66 over 0.66, and another cluster which has an importance score of 0.33. So the feature are split into clearly defined clusters. And in the paper that Ernie and Nancy have written, they point out that the first cluster is referring to more fundamental indicators, and the second cluster is related to more technical indicators, such that stock variance and other things. And now I want to show you the feature selection list. So in the feature selection list, what do you get as output? So there are 10 features, right, which will be selected. And these features, okay, you might want to ask, how are these features selected, right? So first of all, you look at the cluster importance scores, right? And you take the features from that respective clusters whose cluster importance score are higher than the average, right? So in this case, the first cluster will be selected, and all the features inside of that cluster will be used for training the machine learning model. Okay. I will briefly go to the other output. So the performance metrics file, in the performance metrics file is used just for convenience. So in the performance metric file, you just get this simple information that is displayed here, but you might want to download your files at a certain point. And you might want to compare your the performance of your models and the predictions offline. So this might come in handy. I will go to the actual predictions now. I want to go to the out of sample ones first, since we don't have much time, and I want to show as much as possible. So regarding the predicted targets, right? What are the predicted targets? Basically, these are the labels that are going to get predicted by the model. So you get a simple CSV file like this. In the sense, you have one column with the corresponding months, and now you will have two columns. One is the true target, and one is the predicted target. In the true target are actual values. These are the actual labels from your input data frame. Whereas the predicted target, these are the classes which are offered by your predictive model. So you see here some of the months the model got it right. In some, actually in the test set, most cases the model has taken it correctly, but I will take, since the AUC score is not superior, that would mean that this result will be taken with a grain of salt, because we know that in this regime, it had been a bull market. So most of the predictions will be labeled as 1. Okay. And regarding predicted probabilities, I think that would be that might come handy, because first of all, you might want to use the predictions per se, 0 or 1, profitable or unprofitable. But the idea is, since you might not like a black box model, you might want to look into the actual probabilities that the model output. So you might use this machine learning model technique to size your trades. So you might want to look into using it as a risk management layer. So for instance, if your model tells you that there is about 60% chance of your trade being profitable, you might size your capital accordingly. Or you might also have it as a threshold, saying, okay, I'm not going to trade anything unless it's great, unless the predictive, the model tells me that the trade is going to be profitable with more than 65%. So you might use it for different use cases. Okay. Now I want to very briefly show you the live mode. So in the live mode, you perform new predictions for new data. So now I want to download the model file. Yes. Now I will go back to the main dashboard and click on the live mode. Okay. And in the live mode, I need to upload a live data set. Now, how does the live data set looks like? It is, you might use it differently, but usually in practice, it is you're training a model using historical data, and then you decide whether you trade or not. So in this case, for December 2019, I'm trying to predict whether the January, so at the end of December 2019, I want to predict whether the January monthly return will be positive or not. Now, you see the format here is consistent to the format of your input data set. Of course, the values will differ, of course, but you will see here that the returns column had been left empty, meaning that you don't know in advance whether your trade is going to be profitable. Okay, and once you, so first of all, let me choose that. I think this one, yeah. Okay, and now you need to upload your model, and let me look at here. Yeah, I think this one. Let me look. Hopefully I didn't get it wrong. Okay, so I think it's this one. Okay, so I'm going to click on predict. And indeed, as output, you get 2 CSV files. In the first CSV file, you have the predicted targets, right? So for this month, right? At the end of December, I want to see whether at the end of January, the returns, the monthly return is positive or not. And in this case, it said, yeah, it's positive. Okay, so I might trade on that. Now, in terms of predicted probabilities, again, if you look at the confidence that the model has in this prediction, it says, oh, over 90% chance of your model being profitable, of the returns being strictly positive. And with that, I will conclude this demo.